So this is class number 4 of module number 4. Okay, and in this uh, in this class we are going to solve one more problem on knife edge follower. Yeah. Again, in this problem we have to draw a displacement diagram. You can see here. So this is the displacement diagram, and this is the cam profile. Okay, and we'll start with the second problem. So please note down the keywords wherever required. So first I'll read out the problem statement. A cam with a 3 centimeter as a minimum radius is rotating clockwise at a uniform speed of 1200 rpm and has to give the motion to the knife edge follower as defined below. So it means you can see here there is a cam with a minimum radius of 3 centimeter, and whenever the word comes minimum radius, it is nothing but the base circle radius. Please note down. So wherever the word comes minimum radius, it is nothing but the base circle radius. You can indicate with a capital R. So which is nothing but 3 centimeter, and it is given that the cam is rotating in a clockwise direction. So you can see here again the cam is rotating in a clockwise direction. So this is the approximate the pattern or the outer surface of the cam. Okay, this is not the exact one. So I have taken an example of how the cam surface may be. It may be of any shape other than a circular nature. It may be of any shape. Okay. So I have taken elliptical for my convenience, and it is also given that the cam is rotating with a speed of 1200 rpm. It means the capital N is given. The speed of this cam is given. That is 1200 rpm. And also the type of follower is nothing but a knife edge follower. Just confirm this. Okay. So it may be sometimes it may be a roller type also. For that there is a separate method is there. And I'll confirm that the type of follower is knife edge. So you can see this is the knife edge follower. As the cam starts rotating from 0 degree to 360 degree, what happens? The follower starts moving in a upward and downward direction. And in between it can take a rest, which is nothing but a dwell. So I can say that the upward motion of the follower is nothing but the outstroke, and the downward movement of the follower is nothing but the return stroke. In between the upward and the return stroke, the follower will remain under rest for certain time. That time period is nothing but the angle covered by cam, which is nothing but a dwell angle. Dwell means the follower will be under rest. There will not be any movement of the follower. So they are given some certain conditions. The follower to move outward through 3 centimeter during 120 degree of cam rotation with a simple harmonic motion. So please note down the keywords. So it is given that whenever the follower is moving in a outward direction or the upward direction, so through 3 centimeter, it means the maximum distance that is traveled by the follower is 3 centimeter, which is nothing but you can say as a stroke length of the follower. It means it can travel maximum up to 3 centimeter. 3 centimeter up, 3 centimeter down. The distance that is traveled by the follower, which is nothing but a stroke length, you have to indicate with a capital letter or small letter S, so which is given as 3 centimeter. And the follower is moving in upward direction for 120 degree of cam rotation. It means when the cam is rotating through 120 degree from 0 to 120, during that time the follower is moving in upward direction. So that's why I can call this as a outstroke angle, theta O. It means during the first 120 degree rotation of the cam, the follower is moving in an upward direction. So I can call it as a outstroke angle, that is 120 degree. And at that time they are saying
Excuse
that,
me, sir.
yeah.
Sir, one student is waiting, sir, to join the class.
Okay. Yeah. And the first dwell angle is nothing but a 120 degree, and it is given that during that outward stroke of the follower, the type of motion is a simple harmonic motion. Just remember, okay? So for the outward movement of the follower, the kind of motion is simple harmonic. Just write down this keyword. After that, after the follower moves in upward direction, for the next 60 degree, of the cam rotation, there will not be any movement of the follower. So it is given 12 for the next 60 degree. So for the first 120 degree of cam rotation, the follower will move in upward direction, and after that, for the next 60 degree of the cam rotation, there will not be any movement of the follower. So it is given that it is at 12. And after that, follower to return to its starting position during the next 90 degree with a uniform acceleration and a retardation motion. After the dwell period, the follower will come down. It means it will return to its original position for the next 90 degree of cam rotation. Okay. First is 120. During that, the follower is moving in upward direction. After that, for the next 60, there will not be any movement of the follower. And for the next 90 degree, the follower will come down. The follower will come down. And it is given that the follower is moving with uniform acceleration and retardation motion. Just note down this. And after coming down again for the next 90 degree, it means for the remaining period, it means 360 minus 90 minus 60 minus 120. It means for the next 90 degree, there will not be any movement of the follower. Again, it is under rest. It is given 12 for the next remaining period. First, outward motion, again it will take rest. Again, the downward motion, again it will take rest. First one is outstroke angle, that is 120. Next, first dwell angle 60. After that, return stroke angle 90 degree, and second dwell angle is again 90. So you can calculate. Total is 360. 360 minus 90 minus 60 minus 120. The remaining period means it will be the remaining angle that is covered by the cam. So these are the four angles. Okay, you have to calculate the last one. The fourth one you need to calculate. And after that, you need to draw the cam profile for the following cases. There are two cases are given. One is the follower axis passes through the cam axis. It means the follower axis passes through the cam axis. So which is nothing but a radial follower. And one more is the follower axis is offset to the right by 1 centimeter. So this is nothing but the offset follower. There are two types of followers, as I explained in the introduction of this cam. So you can see here. So this is nothing but a radial follower. So I have explained this in the first class or the second class. This is the radial follower, in which you can see the axis of the follower is passing through the center of this camshaft. So this is nothing but a radial follower. In the second case, you can see the axis of the follower is offset to the right with respect to the center of the camshaft. So this is the axis of the camshaft, you can say, and this is the axis of the follower. So there is some gap between both the axes. So it is towards right. It means offset towards right. In this case, it is 16 centimeter. So for these two cases, you have to draw the cam profile. So that is the given thing. Yeah. So these are the two conditions. And it is given that the follower axis is offset to the right. Just to confirm that whether it is right or left by 1 centimeter. The offset between the axis of the cam and the axis of the follower is 1 centimeter. Don't worry about this one. I'll explain once again while solving the this case, the cam profile for the second case. And one more thing is you need to find the maximum velocity and acceleration of the follower during outward and inward stroke. Inward is nothing but return stroke. Just wait for a second. Yeah. Yeah. So you need to find the maximum velocity and acceleration of the follower during outward stroke and return stroke. Return stroke is also called as inward. Outward means the follower will be moving away from the center of this cam. Inward means the follower will be moving towards the center of this camshaft. So I think this is clear. The first what I'll do, I'll note down the given thing. Okay, I'll start with the solution. Before that, from the given problem, I'll note down what are the given things. So please note down this. The base cycle radius is given as 3 centimeter. So in the problem, they are not mentioned the base circle. As I said, they'll mention as a minimum radius, so which is corresponding to the base cycle radius. Okay, please note on that the minimum radius is nothing but the base cycle radius. So it is given as 3 centimeters or 30 mm. Both are correct. And it is rotating clockwise. It is also important that it is rotating in a clockwise or in a counterclockwise direction with a speed of 1200 rpm. After that, the stroke length is given, that is s is equal to 3 centimeter. It means the maximum distance that is traveled by the follower, which is nothing but a stroke length, which is also 3 centimeter. 3 centimeter. And the first angle, the outstroke angle is theta naught, that is 120 degree with a simple harmonic motion. Just write down in the bracket. This is also important. And for the next 60, there is a dwell of the follower. It means there is no movement of the follower. I can call it as the first dwell angle, that is a theta d1, that is 60 degree. After that, the follower will come down for the next 90 degree, which is nothing but a return stroke angle, that is theta r, that is 90 degree, with uniform acceleration and retardation motion. So this is the difference from the first problem and the second problem. So in the first problem, we have seen that both the outstroke angle and the return stroke angle both are with simple harmonic motion. So this is also simple harmonic motion. This is also with simple harmonic motion in the previous case, in the previous problem. But in this case, the outstroke angle is with simple harmonic motion and the return stroke angle is with uniform acceleration and retardation motion. So this is very important. And after that, the second dwell angle, that is a theta d2, is a 90 degree. This is not given. So they are saying that a dwell for the remaining period. It means total is 360. Okay, 360 minus 90 minus 60 minus 120. The remaining is nothing but 90 degree. Okay, for the last 90 degree, there is a dwell of the follower. So have you noted down these given things so that I can move to the next slide? Anyone? Yeah, I'll go to the next slide. So these are the given things. These are very important. These four angles are very much important. So please remember this: 120, 60, 90, and 90. Yeah, we'll go to the next slide. That is a list of formula. So out of these three set of formula, which one you have to use? Okay, it is given that the outstroke motion of the follower, the outstroke is with simple harmonic motion, correct? So I'll take this one. The outstroke is with a simple harmonic motion, so that I'll consider these two formula to find the maximum velocity and the maximum acceleration of the follower. Please note on this. So it is given in the problem. The outstroke angle is with simple harmonic motion with 120 degree. It is given in the problem. You can see it. The outstroke is with simple harmonic motion, that is 120 degree. So that to find the maximum velocity and the acceleration during outstroke, I'll use this formula corresponding to simple harmonic motion. So please write down this: V naught max is equal to pi by 2 omega s divided by theta naught. Theta naught is nothing but the outstroke angle, and this the maximum acceleration during the outstroke, that is a pi square by 2 omega square s theta naught square. Yeah, and after that, it is given that the follower will come down, or the return stroke, with a uniform acceleration and the retardation motion. It is given in the problem. So that's why for the return stroke, I'll select this formula corresponding to the uniform acceleration and retardation motion. That is the maximum velocity during the return stroke, that is a VR max, is equal to 2 omega into s divided by theta r. Theta r is nothing but the return stroke angle. So this is the maximum acceleration during return stroke, that is AR max, which is given by 4 into omega square s divided by theta r square. Okay, where omega is nothing but 2 pi n by 60, n is nothing but the speed of the camshaft, which would be in rpm. S is nothing but the stroke length, that is 3 centimeter. You need to convert into meter. Theta naught is the outstroke angle, which should be in radians. Theta r is also it is a written stroke angle, which has to be in radians. Please note down these two formulas so that I can go to the next slide. Yeah. So first, what I'll do for the outstroke motion, which is nothing but with a simple harmonic motion, using those formula, I'll write down the formula. Okay. As for from the list of formula, you can see for the outstroke, the formula for maximum velocity is this one, and the formula for maximum acceleration is this one. I'll copy the same thing. That is, the V naught max is equal to pi by 2 into omega s divided by theta naught. So to find this maximum acceleration during outstroke, I want this one. Omega is not given. S is given, theta naught is given. To find the omega, just use this formula. Omega is equal to 2 pi n by 60. N should be in RPM. It is given. That is, speed of the cam is 1200 RPM. Just substitute the values. You'll get omega, the angular velocity of the cam, as 125.664. It should be in radian per second. You'll get the answer in radian per second. So after getting the value of this angular velocity omega, just substitute this in this formula so that you'll get the maximum velocity during outstroke. V naught max pi by 2 into omega. Omega is this much. I'll write down this. S is nothing but the stroke length, which is given as 3 centimeter. So I want in meter. It means 3 into 10 raised to minus 2. And theta naught, the outstroke angle, which is 120. But I need to substitute in radians. Just multiply with pi by 180 so that it will become in radians. 120 is in degree. So 120 into pi by 180. So that the theta naught will be in radians. So finally, you'll get the maximum velocity during the outstroke as 2.8274 meter per second. So after that, similarly, I'll use the formula A naught max, which is nothing but the maximum acceleration during the outstroke. So you can see here both the formula for outstroke. Outstroke means V naught, A naught. Again, use the same formula. You just substitute the value of omega s and theta naught. You'll get the A naught max as 532.96 meter per second square. Anyone just tell me whether you're getting the same answer, V naught max and A naught max?
Yes, sir.
Okay, thank you. So if this is clear, I'll go to the written stroke. The outstroke is over. Next is a written stroke, and it is given. It is with uniform acceleration and retardation motion. I'll write down the formula corresponding to this UARM, uniform acceleration and retardation motion. And these things were already discussed in the second class during the introduction of the cam. Please go through that. If any doubts, please go through that. And the formula for maximum velocity is 2 omega s divided by theta r. Omega is known, that is 125.664. S is 3 centimeter, 3 into 10 raised to minus 2 meters. And the written stroke angle is given as 90 degree. I want in radians, so I'll multiply with pi by 180. So I'll get the VR max as 4.8 meter per second. And after that, maximum acceleration during written stroke is nothing but AR max is equal to 4 omega square s divided by theta r whole square. Just substitute all the values. You'll get the answer as 768 meter per second square. Just please take a 30-second time. Just calculate these values and tell me whether you're getting the similar answer. So anyone, at least you are getting the first one, the VR max as 4.8 meter per second.
Yes, sir.
You can calculate later also. You just substitute these values directly, whatever it is appearing on the screen. You should get this answer.
Sir, S is how it's given. 3 into 10 raised to minus 2.
S is nothing but the stroke length. It is given in the problem. For example, I'll go to the first. Yeah.
Yes, sir, getting, sir. Same.
Okay, correct. Okay, stroke length is nothing but S, 3 centimeter.
760.
Correct.
7.95.
Correct. Very good. S is nothing but this one, 3 centimeter. So 3 centimeter means 3 into 10 raised to minus 2 meter. To convert into meter. So 3 into 10 raised to minus 2, or you can say 0.03. 0.03 also correct. Yeah. So I hope this is clear. I'll go to the next slide. After calculating the maximum velocity and acceleration during outstroke and return stroke, I'll go with the displacement diagram. Okay. So this is the displacement diagram you need to draw. Okay. So I'll explain how to draw this one. Okay, in the next slide, I'll explain how to draw this displacement diagram. It is not mentioned in the problem, but to draw the cam profile, you need all these values, 1 to 1 dash, 2 to 2 dash. Okay. For that, you need to draw the displacement diagram. So this carries 10 marks. Okay, if the problem total is 20 marks, so the problem the previous slides and this slide carries 10 marks. And after that, you need to draw the cam profile. This carries 5 marks for the radial follower. So this is the cam profile you need to draw for these 4 angles. So please mute your audio. Anyone? Please mute your audio. And the second case, offset follower. You need to draw the cam profile for the offset follower. So this carries 5 marks, total 20. Okay. So what we'll do in the next 20 minutes, I'll try to complete this displacement diagram. Okay. And after that, in the next class, I'll go with the cam profile for the radial follower and cam profile for offset follower.
Sir, how many marks for total problem?
Total 20 marks. A single problem you'll get 20 marks.
For displacement diagram?
10 marks, including the calculation of maximum velocity and acceleration along with this displacement diagram carries 10 marks.
Cam profile 5 marks.
5 plus 5. So this is 5 and this is 5. So this is the fixed problem. Only they'll change the angles. They'll change the angles and they'll change the type of motions, whether it is with a simple harmonic motion or with a uniform acceleration and retardation motion. Okay. So let me explain in the next slide. Okay. So please remember these angles. The outstroke angle, that is 120, first well angle 60, and the return stroke angle 90, and the second well angle is again 90. Just keep in mind 120, 60, 90, 90. And just remember the stroke length, that is 3 centimeter. So if it is clear, I'll go to the displacement diagram with a step-by-step explanation. Okay. So first, I'll take the same scale, whatever I've taken for the previous problem. I'll take the same scale. So along the x-axis, I'll plot the cam rotation angle, that is from 0 to 360. The rotation of the cam is plotted along the x-axis. I'll take the scale as 1 centimeter is equal to 20 degree. 1 centimeter is equal to 20. It means I want to indicate total 360. It means how much? 360 by 20. How much? We have to draw 18 centimeter. 18 centimeter.
18.
Correct. 1 centimeter is 20. 2 centimeter means 40. 18 centimeter means 360. Total 360. And along y-axis, can see here it is a stroke length. It means that the follower motion, the distance traveled by the follower. Okay. It has to be indicated along the y-axis. I'll take the scale as 1 centimeter is equal to 1 centimeter stroke length. So what is the maximum distance that is traveled by the follower? Anyone? The stroke length is given.
3 centimeter.
3 centimeter.
3
Correct.
centimeter.
Correct. So I'll indicate 3 centimeter along y-axis. Okay. After that, I'll complete one box. I'll complete one box. It means you are plotting the distance traveled by the follower for different angles. For the first 120 degree, what is the distance traveled by the follower? For the next 60, what is the distance? It means you are plotting the distance traveled by the follower along corresponding to the cam rotation. Cam rotation. So if you want, I can show the animation. I can see this animation. So the cam is rotating through 360 and the follower is moving through some distance. For the first 10 degree, what is the distance traveled? For the next 20, what is the distance traveled by the follower? Okay, you are plotting the distance traveled by the follower against the cam rotation. So this was already explained in the previous class. I'll go to this displacement diagram. Yeah. So after indicating the scale, so first I'll indicate the outstroke angle. What is the outstroke angle? First
120 degree.
120 degree, correct. 120. So as per scale, how much it is?
6 centimeter.
120 by 20. That is
6
nothing but
centimeter.
6 centimeter. Correct. Because the scale is 1 centimeter is equal to 20 degree. I want 120 degree. It means 120 divided by 20. 6 centimeter. So you can see here. The outstroke angle, I'll write, it is with simple harmonic motion. That is 120. So as per scale, 120 divided by 20. So it will become 6 centimeter. And what is the next? The first dwell angle?
60 degree.
60, correct. The first dwell angle is 60. It means the 60 divided by 20, it will become 3 centimeter.
3 centimeter.
Correct. For the next 3 centimeter, I'll indicate the first dwell angle. After that, the next angle is return stroke angle, 90 degree. Correct. 90 by 20, it becomes 4.5. 4.5 centimeter.
4.5.
Correct. And just write this return stroke is with uniform acceleration and retardation motion. So this is the difference. The first problem, both the outstroke and the return stroke are with simple harmonic. So the method to draw the displacement diagram is same for both outstroke and the return stroke. But in this problem, it will changes. It will be different because the outstroke is with simple harmonic motion and the return stroke is with uniform acceleration and retardation motion. Now after that, what is the last angle? The second well angle? 90, correct? Sir, no. 90 or not? Yeah.
Yes, sir.
Yes, sir.
Yeah. The second dwell angle is 90. 90 by 20 is again 4.5. So you can do the summation of all the these distances. 6 plus 3, 9. Again, this 4.5, 4.5. Total is 18 centimeter. So you have indicated all the 360 from 0 to 360. First 120, then 60, then 90 and 90. So after that, the next step is to divide this outstroke angle into 6 equal parts. I'll divide this 6 centimeter into 6 equal parts. How much it becomes? Each division 6 by 6 is 1 centimeter. So using the scale, I'll divide this total 6 centimeter, which corresponding to the outstroke angle, into 6 equal parts. So 6 divided by 6. So each division becomes 1 centimeter. 1 centimeter, 1 centimeter, 1 centimeter, similar. And after that, I'll not worry about this dwell angle. Directly, I'll divide the written stroke angle. So how much? The total is 4.5 centimeters. The written stroke angle is 4.5. I want 6 equal parts. How much each division? Anyone?
7.5.
Correct. 0.75 centimeter. So before dividing that, you can give the naming also. For these 6 equal parts, I can give the naming as a 0, 1, 2, 3, 4, 5, 6. So after this, each division becomes 0.75 centimeter. Correct. 0.75 centimeter. You can see here all the dimensions are in centimeters. Yeah. So after that, since it is a written stroke, it means the follower is coming down. I'll give the naming in a reverse order. It means I'll start from 6, 5, 4, 3, 2, 1. You can see it. 6, 5, 4, 3, 2, 1, 0. Okay. Up to this, these steps are same for all the problems. It may be of anything. After this, the steps are same. So you have to indicate the outstroke, first well angle, written stroke, next the second well angle. After that, you have to divide the outstroke into 6 equal parts. Again, give the same namings. Again, divide the written stroke into 6 equal parts. Again, give the naming in a reverse order. Okay. After this, I'll confirm the outstroke is whether with a uniform velocity or with a simple harmonic motion or with a uniform acceleration and retardation motion or the cycloidal. There are 4 types. Okay. And it is given in the problem the outstroke is with a simple harmonic motion. And for that, so the method is similar to the previous one, that is semicircle method. Remember, whenever the word comes simple harmonic motion, you have to use the semicircle method to draw the displacement diagram. Okay. So that is nothing but what I'll do, I'll take this 3 centimeter, the midpoint of this 3 centimeter, that is from this reference point 1.5. I'll take the center point. I'll draw a semicircle with a radius of 1.5, and I'll take the midpoint of this outstroke, this stroke length. The stroke length is 3 centimeter along the y-axis. So from this reference point, I'll indicate the center, that is 1.5. So and using the compass, I'll draw a semicircle. I'll draw a semicircle with a radius of 1.5 centimeter. After that, using the protractor, you have to divide this semicircle into 6 equal parts. So this semicircle is having total 180 degree. So I want 6 equal parts. It means 180 by 6, 30 degree. Using the protractor, 30 degree, correct, 30. Using the protractor, so just place the protractor here in such a way that the 0 degree of the protractor will be in line with this vertical axis or the y-axis. Okay, and the midpoint of the protractor will be at this point, exactly here. Similar to the semicircle, just keep your protractor and just indicate the angles 30, 60, 90, 120, 150, 180. So you can mark over the circumference of the semicircle. So like this. Okay, I got 6 equal parts. First, second, third, 4, 5, 6. Each division with 30 degree. After that, I'll give the naming. I'll start from here. This is A, so you can zoom in here. Okay. So this will be A, B, C, D, E, F. Yeah. So please zoom this area so that you'll get a clear idea. You can see here. So this is A, B, C, D, E, F. Okay, this is also same as in the previous case, similar to the previous problem. After that, the next step is from each these alphabets A, B, C, D, E, F, just draw the horizontal lines. with respect to this only the outstroke, because this method is only for this outstroke. So draw the horizontal lines from these alphabets A, B, C, D, E, F. So like this, you'll get 6 horizontal lines. You get 6 horizontal lines. You can see here. So the first line that is coming from A, the second is coming from B, C, D, E, and F. Okay, just please zoom this area so that it will be clear. After this, you can see here the first line, the first horizontal line, which is coming from point A, it will intersect the first vertical line. So that is indicated with 1 at this point. So this is nothing but 1 dash. And the second line, which is coming from B, it will intersect the second vertical line at this point. So this is the 2 dash. Similarly, 3 dash, 4 dash, 5 dash, and the 6 dash. So just first locate the intersection points between the horizontal lines which are coming from A, B, C, D, E, F, and the vertical lines which are coming from 1, 2, 3, 4, 5, 6, and give the namings. So I have indicated. So you can see here. So the intersection between the first horizontal line and the first vertical line. So this is 1 dash. Similarly, 2 dash, 3 dash, 4, 5, 6 dash. So after that, just draw a freehand curve passing through all these 6 points. So like this, you can see the red color line. So which is nothing but the displacement drawing for this outstroke angle. It means for the first 20 degree, what is the distance traveled by the follower? For the next 20, what is the distance? Okay, you're plotting the stroke length against the cam rotation angle. So this is the curve you're going to get for the outstroke angle, which is with simple harmonic motion. Remember, this is a semicircle method which is only used for the simple harmonic motion, whether it may be the return stroke or the outstroke. Okay, just keep in mind. So this is the semicircle method which has to be used for simple harmonic motion, irrespective of whether it is outstroke or return stroke. So after that, for the next 60 degree, there is no movement of the follower. That's why it is called as a dwell. Dwell means there is a zero displacement of the follower. It means the follower remains in the upward position only. After traveling through 3 centimeter, it will not come down immediately. Okay, so it will take some rest for the next 60 degree of the cam rotation. The cam will be rotating continuously. Okay, so from 0 to 120, 120 to 60, again for 90 and 90. There is no rest for cam. Only the follower will take some rest. It means in this problem, for the next 60 degree of the cam rotation, there is no movement of the follower. It means the curve become flat. You can see here the curve is flat. Yeah. So after this, I had to draw the displacement diagram for the return stroke for the next 90 degree. So this is the return stroke angle. And just confirm whether it is with a simple harmonic or with a uniform velocity or for uniform acceleration and retardation motion. But it is given that the return stroke is with uniform acceleration and retardation motion. Okay, to plot the displacement diagram for this uniform acceleration and retardation motion, there is a separate method. So first, for that, what I'll do, first I'll take out of these 6 vertical lines, that is 6, 5, 4, 3, 2, 1, 0. I'll take the middle one, that is the third vertical line. So you can see here, just zoom this area so that it will be clear. Please zoom this area. So I'll take the middle vertical line, and what is the height of this middle vertical line? It is 3 centimeter. You can see here, the height of this vertical line is 3 centimeter. 3 centimeter. What I'll do, I'll divide this vertical line into 6 equal parts like this. So each of 0.5 centimeters, 0.5, 0.5, 0.5. Total is 3 centimeter. And after that, what I'll give, I'll give the namings, that is A, B, C, D, E, F. So you can see it. So A, B, C, D, E, F. For these 6 divisions, I will indicate with alphabets. So what I've done, I've taken the middle line of these 6 lines, and I have divided this middle line into 6 equal parts. The height of this line is 3 centimeter. So I want 6 equal parts. 3 by 6, 0.5, 0.5, 0.5, 0.5. So after that I have given the namings A, B, C, D, E, F. So after that what I'll do, since the follower is coming down, it means it is returning to its original position. It means the curve has to come down. So here it is rising, then again the flat. Now the curve has to come down like this. So for that case what I'll do, I'll draw a diagonal passing through this point C in a downward direction from the left top corner to the right bottom corner of this box. So I'll draw a diagonal in a downward direction. So why I'm drawing a downward diagonal? Because the follower is returning in a downward direction. It is coming down. Okay. So what I'll do, I'll draw a diagonal starting from this point. I'll join here like this. You can see here. Again, I'll continue this up to this point O. So I've drawn a diagonal in a downward direction because the follower is coming down. If the follower is going up, you can draw a diagonal in upward direction from like this. Okay. So after this, what I'll do, I'll take this as a reference point. I'll draw a line which will join from this point to this point, like this, and one more line like this. So initially you may feel difficulty, but after solving a couple of problems, it will be easy. So I have joined this point to point E, and again from this point to point D. So again I'll take this as a reference point. The bottom rightmost corner, this one, I'll draw one more line that will join point A and point B, like this. Again I'll explain once again. I've taken the middle line out of these 6 lines, and I have divided.
Sir, why you taken?
Yeah, come again once again. What is the doubt?
Why you taken that middle line?
So
This
that is
method.
that is the method used for this uniform acceleration and retardation motion. This is the standard method.
Okay, sir. Uniform
Acceleration and retardation motion. Retardation means deceleration, acceleration and deacceleration.
Okay, sir.
Okay. So it is given in the notes. You can go through that in the first introduction part. So I have given the step-by-step explanation. Whatever explaining the same thing, it is there. Just go through that note, and remember this is standard method. Okay. And after that,
In that question, they are mentioned.
they'll mention whether this is with a uniform acceleration and retardation motion.
Okay, sir. Okay.
Okay, they'll mention. So after this, I have given the alphabets A, B, C, D, E, F. After that, I'll draw a diagonal passing through the left top corner and the bottom right corner like this. So I've drawn a diagonal passing through point C. Then I'll join this point to point E and this point to point D with a straight line. So this is also under this method only. Again, I'll take this right bottom corner. I'll join a straight line like this. And just zoom this area. The next step, I'll explain how to indicate the intersection points. So these are the 6 lines, 6 vertical lines. That is the 6, 5, 4, 3, 2, 1, 0. And these are the 6 inclined lines. You can see this is also inclined, inclined, inclined. Okay. The intersection between these inclined lines and these vertical lines, which are nothing but 6 dash 5, 4, 3, 2, 1, 0. Okay. So first, this will be the 6th line, correct? This is the 6th line, and this first I'll take this as a 6 dash. Okay. Now after that, so first let me show the intersection points. So these are the blue dots, which are nothing but the intersection points. I'll give the naming 6, 5, 4, 3, 2, 1, 0. So you can see the first intersection point. So I'll take this as a continuation. This is a continuation from the previous angle, that is the outstroke angle. This is a rising curve. After that there's a dwell. So I'll start from here. I'll continue from here. So this is 6 dash. Since it is coming down, I'll take in the reverse manner. that is 6, 5, 4, 3, 2, 1. So this is the first point, and after that you can see the fifth line, this fifth vertical line, and this first inclined line, okay, which is joining point E. So this is the first inclined line, and this is the fifth line. They're intersecting at this point, so you have to indicate that as a phi dash. And this is the second, the inclined line, which is joining point D. It will intersect the next vertical line, that is the fourth one. Okay, that is nothing but 4 dash. After that, this is the third inclined line, so which is intersecting this third vertical line. This is the third vertical line, and this is the third inclined line. So this intersection point I'll indicate as a 3 dash. Again, I'll take this one, this inclined line which has started from point B. So this will intersect the second vertical line at this point. Just observe this. This is the second vertical line, you can see here, and this is the inclined line, and it will intersect at this point. So I'll indicate as a 2 dash. Similarly, the last line is nothing but the vertical line number 1. So it will intersect with this inclined line which has started from point A at this point, 1 dash. It means all these are nothing but the intersection between the 6 vertical lines and the 6 inclined lines as shown in this figure. So after getting these 6 points, 6, 5, 4, 3, 2, 1, 0, you have to draw a smooth curve just to pass through all these 6 points. Yeah, like this. So you have drawn a freehand curve which has to pass through all these 6 points. So which is nothing but the displacement diagram for written stroke angle. After that, for the next 90 degree, there is no movement of the follower. It is given. The follower is under rest for the next 90 degree. It means the curve will be again flat. So you can zoom this area. So this again the curve is flat. So this completes the complete displacement diagram for the outstroke and as well as the return stroke angle. And in the next class, I'll draw the cam profile for the 2 different conditions. I'll draw the cam profile. And if you're having any doubts in this displacement diagram, you can ask. Otherwise, I'll wind up for today's class.